Hello, I'm Huiling, and I'm doing my PhD in the Aeronautics Department, and I'm also a fellow of the Software Sustainability Institute. Today, I'll be introducing you to Git branches, how it's a useful tool for your research even without collaborating with anyone. Last time, we looked at how to craft an effective Git history. The first step to an effective Git history is by having good commit messages. These start with a one-line summary and provide the rationale behind the change. The second step is to craft atomic commits which only have one logical change. In turn, such commits make it easier to write effective commit messages as they are focused on a single logical change. In addition, we covered the 5 benefits of atomic commits and the importance of having effective tests. When you start a project, your local Git repository is initialized with a branch called main. If you use it as is, each commit will be added to the main branch. Each new commit is added to the head of the branch. To conceptualize head, I like to think of it in terms of a video game. Head is like the most recent save or a checkpoint that I've reached. My progress will not be saved until I create a new save or reach the next checkpoint. In the world of Git, this would be creating a new commit. When a new branch is created, it's created from the head of the branch you came from. In this case, it's main. Each subsequent commit on the new branch will be from the head of the new branch. This is a demo of how to create a new branch. I'm going to start by checking out to master to guarantee that I'm on that branch, as my new branch uses the head of the branch that I came from. To create a new branch, I'll run git checkout-b with the name of my new branch. Running git status shows that I'm on my newly created branch. I'm now going to introduce a change in my readme markdown file. Finally, I'm going to commit this change to my new branch. The git log of the last 4 commits shows this newly created commit on my new branch. As you can see, creating a new branch and committing to it is fairly straightforward. The workflow is exactly the same, except that there is an extra step of creating a branch. So, what is the point of having branches when you're not collaborating with anyone else? A core tenet in Git and to the use of branches is ensuring that there is always a working version of your code. Crucially, this working version should not be hard to find. If you need to comb through existing commits to find a working version, then it defeats the purpose of it. Typically, this takes the form of ensuring that anything on the main branch works. All commits are working based on some measure of correctness. The best way is through tests. If any part of the code is broken, then it should not be committed to the main branch. This is why it's important to protect your main branch from errant commits. It's a record of all past working versions of your code, and it's usually where you would want to branch off from. With this core tenet in mind, the next reason for using branches is organizational. With branches, it's possible to group a set of changes together to mark them as being related to a specific thing. This helps to keep the work organized and to keep each component self-contained. This Git graph shows that there are 2 branches, main and feature 1. On the feature 1 branch, we can see the commits 2 and 3 with the hex words cafe babe and dead beef. These are related to feature 1. Even when these commits have been merged back into the main branch, it'll still be possible to see that they are related to this feature. This means that when you're looking at the Git history down the line, you'll be able to identify that they were related to this feature, thereby adding another dimension to the information available. When dealing with the demands of research, I often find myself working on more than one thing at once. Sometimes, it's on 2 separate features. Other times, it's experimenting with 2 different implementations to figure out which one would work. With branches, I can have each set of changes on its own branch. This keeps the work separate, isolating them so I don't pollute one set of changes with another. This also facilitates the creation of atomic commits as the changes are separated. When working with multiple branches on the same copy of the code, a common pain point is dealing with conflicting changes when switching from one branch to another. Git worktree can be used to remedy this pain point, allowing you to take multitasking to the next level. This is a demo of Git worktree. I'm going to begin by showing you the contents of the parent directory. Here you'll see that there are 3 folders. The folder that I'm in at the moment is called Git for Researchers. Now, I'm going to create a new work tree. For this work tree, I'm going to specify that the changes should be tracked with a new branch called Demo Work Tree, and that it should be placed in a newly created folder in the parent directory called Git for Researchers Work Tree. Running git status in my current directory shows that I'm still on master, and the contents of the parent directory contains our newly created directory. When I move into this new directory and run git status, it shows that I'm on my newly created branch called Demo Work Tree, which is up to date with master, and that the working tree is clean. With the work tree, you can continue working with it like a normal copy of your code, creating branches as you please. Creating another clone of your repo would have a similar effect. The main difference is that these 2 clones are not related. With Worktree, pulling in the changes from master into one of them would update master on all the work trees. If you've used Git Stash before, Git Worktree shares the stash between the work trees. When writing code, especially when working with a new tech stack or a package, I end up experimenting with the package to figure out how to use it, or when I encounter a strange bug, it sometimes takes a fair amount of experimenting before figuring out what might be a viable fix. As a core tenet of Git is to always ensure that you have a working version of your code, I do this exploration on a new branch where I could mess everything up and not worry about the consequences. If I'm extending the functionality of the code that I'm developing and I'm unsure about whether it would even work, or perhaps answer the scientific questions that I have, I create a new branch like this off the main branch. Alternatively, if you already have something working and you want to try something different, but you don't know if it'll work, then you can create a new branch from that feature branch to test out your implementation. What happens to this branch depends on the outcome. If the experiment goes well, then these changes can be merged back into the feature A branch. If they don't, then you can just switch back to the feature A branch and the changes will be discarded. Finally, the main reason to why most people use branches is because it facilitates collaboration through distributed development. As each person has a version of the code to work with and can do whatever they want without fear of messing up someone else's code, they can develop features independently. We've seen the rationale behind the use of branches, but how should we manage the way we create the branches? There are infinite number of permutations, and if we're not careful, after a couple of years, you'll be drowning in branches and unsure about what is what. Moreover, the good practice recommendations from industry don't really work for research. If you're working on a simple project without collaborators, then we want to start with a main branch. If there's no reason to create new branches, then we'll keep working on the same branch. This is an example of when you should apply the software engineering principle called KISS, or Keep It Simple, Stupid. There is no need to add complexity if it's not needed. If you have unfinished or untested ideas, then a new branch should be created for this purpose. Whenever you reach a new important milestone, for example, that version of code was used in a paper or you implemented an important set of features, then tags should be used to mark this milestone. If you're unsure about a change, you should create a new branch. Or if you don't know what to do with a change, then it should be committed to a new branch as well. When working with others, you'll want to create a new branch for each feature or fix that you work on. This ensures that each person is working on their own branch. When changes are ready to be merged, they should be reviewed by another collaborator to check the implementation and the style. Personally, I've found having others review my code is a great way to learn from other members of the team, and it often makes me rethink my code. They also often catch bugs or ask about aspects which I had not previously considered. Reviewing other people's code is also a great opportunity to know what other people in the team are working on and to learn from them. After all, the best way to learn how to write great code or how not to write bad code is by reading more code and getting feedback on your own code. To enforce the reviewing before merging, write protection can be placed on the main branch, so merges can only occur through a pull or a merge request. Personally, I place write protection on my main branch even without collaborating, as it prevents me from accidentally doing something extraordinarily dumb, which I do on a frequent basis. It runs my test suite to prevent any regressions and allows me to document the implemented changes in the pull request. The core assumption that I work on is that the primary user and developer, i.e. myself, is about as useful as a chocolate teapot and has a near supernatural talent for introducing bugs into the code base. When working with others and pull request reviews become a part of the workflow, it's vital to ensure that each pull request is a manageable size. A PhD-sized pull request is not manageable. Typically, I've found that any feature that I've worked on for more than a month is too large. Just as you aim for atomic commits, your pull request should focus solely on a specific feature or a set of related changes. If the pull request becomes too large, it becomes difficult for reviewers to understand and evaluate the code effectively. Moreover, when so many changes are present, it's a sign that the branch is too ambitious. This puts it at risk of never being completed. This could be due to there being too many merge conflicts or that the target feature is too complex and needs to be broken down further. To summarize, my top tip when working with branches is to regularly pull in changes and to merge into main. Dealing with merge conflicts are never fun, but keeping your code up to date means it doesn't have to feel like pulling teeth. This is the final talk in the series. I hope you found them useful, learned something new about Git, and convinced you that it's the best thing since sliced bread. Thank you, and I hope you enjoyed my presentation.